Hey everyone, welcome to Cracking the Fang interviews. Today I'm going to be talking about a very popular coding problem which has been asked at LinkedIn, Apple, and Google. The problem is number of pairs in sorted array with sum less than x. Let's dissect the problem a bit. So, what the problem says here is you're given a sorted array and they want you to find number of pairs. By pair they mean two elements at once, so number of two element groups which would sum less than x, where x is a given number. Let's look into an example. So here I have a snippet of the problem from Geeks for Geeks, and as I said, you're given this sorted array and you're supposed to find a pair which sums to less than 7. In this case, the only pair that would sum less than 7 is 1 and 3. In the second example, the pairs that sum less than 7 is 1 and 2, which sum to 3. And then 1 and 3, and then 1 and 4, 1 and 5, and then 2 and 3, and 2 and 4. All right. So let's start with, approach number one. How would we solve this problem? The first approach I can think of is the naive approach, where we need to find a pair. So we have two iterators, two for loops. The first for loop starts at an index. You can denote this by I. The second for loop starts at the very next index, j. And we go through each element with j equals to I plus 1. And we go till j less than n, which would be n minus 1. And we check if the pair sums to less than 7 in this case. And we'd find it in the very first step, which is 1 and 3. How would this code look like? There would be a for loop for I, as I said, which would go from 0 to n minus 2. The reason I say n minus 2, I'm assuming you're writing code in Python. N minus 2 would be here, and the very next element would be j, and you'd still be able to form a pair. But if your I is at the last element, you don't really have another element to form a pair, and the question requires us to form a pair. So the other iterator would be j. You'd go from I plus 1 to n minus 1. And you just check here if the sum, assuming array of I plus array of j is less than x. And you'd increment a counter. The time complexity of this approach is going to be O of n square, and which is a good solution. It's a good brute force solution. Now, the natural question in these coding interviews is, can we do better? So whenever somebody asks you, or you're thinking of, can you actually do better? Look at what you have already. So in this case, you have O of n square. What is better than O of n square? One would be O of n, which is linear. The other thing better than quadratic would be O of log n. And when I see O of log n, what comes to my brain is binary search. Now, binary search is able to find one element, right? The time complexity of binary search is O of log n. But here we are looking for a pair of elements. So maybe this is not the way to go. Let's try to optimize it for linear, which is still better than quadratic, O of n square. So the way I'd like to think about this problem is the array is sorted. You're given the array sorted. Can we use this property to eliminate the two for loops and make it maybe one for loop, which would eventually be O of n? So the way I like to think about this, and this is very similar to the other problem, which is two sum, we'll look into that later, is whenever you have a sorted array and you're trying to find a sum, and you have a reference, and you wanna sort of you wanna get closer to the sum or away from the sum, which you have already to match x, which is the given sum. Something I like to do is I like to have two pointers, one which starts from the beginning of the array, the other which starts from the end of the array. Let me call this I and j. And I like to move them towards each other. You can also call these start and end if that makes it more interpretable. All right, so what I'm trying to do here is I add the elements at these indexes, so 11 and 1. I know I need to, so the sum is 12 in this case, and 12 is greater than 7, which is the given value of x. So we need to reduce our current sum to make it less than 7, right? So how do you do that? Since this is a sorted array, you move the end pointer towards the left. So you go to 10. Now the sum is 10 plus 1, which is 11. 11 is still greater than 7. So we continue with that logic and we move the end or j pointer further towards the left. Now the sum is 1 plus 9, which is 10. 10 is still greater than 7. You continue moving the pointer. Now the sum is 8. 8 is still greater than 7. So as soon as you come to index 1, which is 3, the sum is now 4. And 4 is less than 7. And you can use these indexes, which is 0 and 1, to count the number of pairs you'd have. The way you do that is you take the end index and you subtract it from the start index. So j minus I, which is in this case 1 minus 0, and it gives you 1. So there's one pair you can form with these indexes, right? And let's look at another example for clarity. So in this case, you're still looking for sum equals to 7. Let me clear up some space. You start here. Your I is at index 0. Your j is at the last index. The sum is 9. 9 is not less than 7. So you reduce. So you want to move your j pointer towards the left. Now your sum is 8. Is 8 less than 7? No. So you still want to reduce and move your j pointer towards the left further. Now the sum is 7, and 7 is not less than 7, even though it's equal to 7. So you want to reduce your move your j pointer further towards the left, and now you're at 5. The sum is 6, and 6 is less than 7. And let's see how we can count the number of pairs here. I'll put in the index. So in this case, you are at index 4. So you do 4 minus 0, which gives you 4. And then you add 4 to your count. So you count plus equal to 4. The reason I'm adding this to the count is, think about it this way. So every number in this combination will form a pair. So 1 will form a pair with 2, which is 1 pair. 1 will form a pair with 3, which is still less than 7, by the way. And all of this is possible because this is a sorted array. 1 will form a pair with 4, which will give us sum less than 7. Same with 5. So these are 4 pairs that we have added. Now, since we've counted this, counted these pairs between this window from I to j, we want to move the pointer further to count the remaining pairs which could still happen between the next elements. What I mean by that is, what I'll do is move I to the next index now, since we have already counted. So I is here. Now 2 plus 5 is 7, right? And 7 is not less than 7. So you move the j pointer towards the left. Now 6 is less than 7. That is true. So what you do is you count the pair of numbers here. So the index is 1 and 3 where we are at. So 3 minus 1 equals to 2. And you're going to add this to your count, which makes it 6. And what I mean by counting these through indexes is, again, you're at 2 and your end pointer is at 4. The first pair is going to be between 2 and 3, which is 5, less than 7. The second pair that we could make is between 2 and 4, which is 6, which is still less than 7. So in this way, you are able to count the number of pairs by just going through the loop once. And let's try to understand when the loop would actually end. You're looking for a pair. The loop would end when you are no longer able to make a pair, which would happen when both your pointers are at the same element, right? Yeah. So let's look at the code for this to further understand this. The way the code would look like, as I explained earlier, is you'd have your pointers. The start pointer would be at the first index, the end pointer would be at n minus 1, and you want to loop till you're not at the same index. That's why this condition is very important. Left less than right. When left equals to right, both start and end pointer are at the same index, you can no longer form a pair and you want to jump out. And if your sum is less than x, you subtract right from left, the right pointer from the left pointer, and you increment the left pointer. You have to always move the pointer to not count duplicates. At least one pointer has to move. And if that's not the case, meaning your sum is greater, we reduce the sum. The way we do that is we decrement the right pointer, which is also the j or n pointer that we saw earlier. Yep, so this is the code. I'll leave a link for this in the description. Thank you so much for watching the video, and please subscribe and like. Also share the video with your friends if this has been helpful. See you in the next one.